Hello, we are Ingenuity from Northwestern University, and this is New Home. This project is located in Chicago, Illinois, the third most populous city in the US. Chicago has a long history of dense urbanization. In October of 1871, the Great Chicago Fire destroyed a third of the city, providing city planners with a clean slate to design a more efficient street layout. This new standard arrangement gave rise to Chicago's now typical narrow lots. In the early 20th century, as the city grew, the iconic two-flat home design was developed in response to the demand for workforce housing. Today, development pressures, disinvestment, and changing values are diminishing the stock of affordable housing options near the heart of the city. Additionally, rising CO2 emissions, energy usage, and resource waste are leading to harmful environmental degradation on a global scale. To combat these issues, the city of Chicago is in need of more affordable and more sustainable housing options. There are some challenges in designing these homes. The project site is one of the typical narrow lots. The site's narrow footprint constrains the space for the building. Furthermore, Chicago's harsh winters and hot summers make it difficult to balance residential energy production with residential energy consumption. Finally, the higher cost of sustainable construction is often a large barrier to implementation for homes like this. To design a home suitable for our present context and location, the concept of new home is marketable sustainability. In order to be competitive in the market, a home must address buyers' main concerns of financial feasibility and healthy living. To be a sustainable home, it should emphasize resiliency and versatility and environmental consciousness. Our approach to making the home market ready is efficient construction and future-proof design, providing open living, natural light, and bringing nature indoors. The sustainable design focuses on being family responsive, ensuring durability, providing diverse housing, being net zero, reducing consumption, and strengthening the neighborhood. New Home was designed over Zoom by a team of 12 engineering undergraduate students with a variety of backgrounds, all passionate about sustainable building design. New Home is approximately 2,300 square feet, with the main home on the second and third floors of about 1,800 square feet, featuring 2 beds and 2.5 baths. An accessory dwelling unit takes up a large portion of the first floor, providing a self-contained living unit with 1 bed and 1 bath. The home's 11.3 kilowatt solar roof, high-efficiency HVAC system, tight thermal envelope, Greywater Reuse, and other sustainable features give the home an EOI rating of 12 and a HERS score of -22. Now for the design of New Home.
Chicago is in Climate Zone 5A, characterized by cold winters and warm summers. There are frequent fluctuations in temperature, humidity, cloudiness, and wind direction, making it a difficult climate to design for. The site is located in the Lakeview neighborhood in Chicago. It has easy access to many forms of public transit, including trains, buses, and bike sharing. The building lot is a narrow strip of land 25 feet wide and 125 feet long, with a side street to the north, an alley to the south, and 3-story homes on both of its long sides. The proximity of the neighboring homes make natural lighting a challenge for this area. In considering how the goals and challenges affect the design of the building, alternatives for building shape, location of ADU, and roof shape were considered. The basic box maximized the floor space on the narrow lot and had the smallest envelope. A first-floor ADU, being combined with the main house, reduces the energy lost in heating and cooling the space, as well as provides easy access for people who have difficulty with stairs. Finally, a south-sloping roof maximizes the solar potential for making this a net zero home. All of the sunlight which the home receives is from its south-facing end. Thus, we wanted both the main unit and the ADU to have plenty of window area on this portion of the home, with their main living spaces near this light. Hence, the south-tending placement of the ADU within the overall space. The ramp entrance into the ADU, along with its open floor plan, sliding doors, and ADA-accessible wet bath-style bathroom, allows for comfortable living for all levels of ability. Sliding walls utilized in the home allow the smaller lot space to be used more efficiently, giving the owners more flexibility in how they can use their home. Through these optional lock-offs, the purpose of the ADU can vary anywhere from an income unit to an in-law suite to even a quarantine living space. The main home, largely occupying the second and third floors, also utilizes an open floor plan with main living spaces near the southern end of the home. The south living space's double high ceiling elevates the room, opening it up to feel much larger and more welcoming. This living space is an area where the homeowners can comfortably spend much of their time. The large windows in this double high space also allow plenty of natural light for the living room and centrally located kitchen. A moss wall across the kitchen on the second floor offers a unique natural focal piece for the main gathering space of the home, while purifying the air and reducing noise. The use of moss walls rather than a traditional green wall decreases the watering and maintenance needs of the feature, providing all of the visual and health benefits without the extra work for the homeowners. The skylight at the top of the two-story space above the dining area allows natural light deeper into the home, in addition to brightening up the space for improvements in productivity and mood. The master bedroom features a large walk-in closet and private full bathroom with double sinks, and the secondary bedroom also has its own full bath, featuring a smaller corner shower. The washer and dryer for the main home is centrally located between the bedrooms on the third floor, allowing for extra convenience when doing laundry. The third floor also features a small work den, which provides a comfortable working space with natural light. Another workspace exists on the first floor, which can easily be converted into a small office or studio for a small business, maintaining separation from the main home through a staircase and from the ADU through a lock-off. To take advantage of natural light and heating, designing the roof and balcony sun angles allows us to minimize heat gain in the summer and maximize heat gain in winter through our south-facing windows. In the winter months, the lower sun angle will penetrate deep into the home, providing both a greater degree of environmental comfort and also saving on energy usage and costs. In the summer months, the higher sun angle will be blocked by the overhanging roof and balcony, shading the large windows below and keeping the home cool and comfortable. Because the heart of the home receives the most natural light, this can reduce other lighting needs throughout the year, while many of the other areas in the home still receive passive lighting through their windows. To maximize efficiency gains from our passive strategies, HVAC, and PV systems, it is important that we maintain a tight thermal envelope. We use commonly available materials with low embodied energies to save on costs and minimize environmental impact. We opted to go for a 2x4 double stud approach using a combination of EPS rigid foam and dense pack cellulose insulation, as well as a frost-protected shallow foundation. Frost-protected shallow foundations are more resource efficient and less costly compared to a typical foundation wall system due to less excavation and labor necessary for construction. This foundation system takes advantage of the home's heat losses as well as geothermal heat to raise frost depth around the home. A minimal concrete approach involved using a structural fill and 6 inches of EPS slab to provide the same structural support of a concrete slab while increasing thermal performance and lowering concrete use. Additionally, to increase resilience against adverse weather conditions, the frost-protected shallow foundation was designed to withstand colder temperature extremes of climate zone 6A as opposed to climate zone 5A of Chicago. For the main superstructure framing, a double stud approach was chosen for its straightforward construction, use of common materials, low embodied carbon, and compatibility with sustainable dense pack cellulose insulation. Designed such that the roof bears on the outer walls while the floor bears on the inner walls, the framing method results in an efficient, structurally sound building which maximizes the depth of continuous insulation and eliminates thermal bridging at the rim joist. Furthermore, a Class 3 vapor barrier behind the interior gypsum board finish provides protection from adverse moisture conditions, and liquid weather wrap below the exterior cladding provides protection from the elements. At the roof, a combination of dense pack cellulose insulation between the trusses and rigid EPS insulation above the roof sheathing provides a continuous layer of insulation which keeps the roof sheathing above the dew point during the winter and completes the tight thermal envelope. For our home's exterior cladding, using reclaimed wood with shosugiban treatment, a Japanese burning method which preserves and protects the wood, allows us to achieve a unique appearance and a higher degree of sustainability without sacrificing environmental performance. Low E double pane windows trimmed with a high performance G8 coil, and the roof is cladded using standing seam metal roofing due to its unparalleled aesthetic, recyclability, and compatibility with PV mounting.
Building off of that, the water system of new home is specially designed to maximize ease of construction and occupant comfort while minimizing water use. This is reflected by our water core design, in which all of the pipes and water fixtures in the home are all centralized within the same interior wall of the building. The water core features WaterSense certified low flow fixtures and Energy Star rated water appliances to reduce indoor water use. By vertically stacking the wet components of the house, new home can dramatically cut down on the amount of stagnant water sitting in the pipes, thus reducing hot water waiting time. In addition, the centralized plumbing system also lends well to prefabrication, as the entire water core can be constructed elsewhere and simply installed on site, decreasing manufacturing costs and the amount of raw materials needed. Cold and hot water manifolds containing a series of valves to shut off water lines are also installed in the second floor MEP room, making day-to-day maintenance and plumbing checkups easier than ever. To further minimize the potable water footprint of the home, new home comes with 5 low-tech, easy-to-maintain sink-to-toilet greywater systems and an Aqua-to-Use Pro laundry-to-landscape greywater system. The sink-to-toilet greywater system works by rerouting the used water from bathroom sinks to a dedicated water filter, then feeding that filter water into the adjacent toilet cistern where it is used to offset flush fixture water use. Similarly, the laundry-to-landscape greywater system on the right cleans used water from the washing machine in the home and delivers it to the backyard where it is used for irrigation. As such, the impressive 65% of flush fixture water and 16% of the landscaping water can be replaced with greywater.
Once the greywater reaches our backyard, it is delivered via subsurface pressure compensated drip irrigation emitters, which offer protection from frost, prevent small children or wildlife from accidentally ingesting greywater, and deliver water consistently regardless of pipe pressure. New Home's landscaping design features a variety of xeriscaping strategies, such as adopting native plants like buffalo grass and butterfly bush in lieu of traditional water-demanding plants. Permeable pavements are also used on all of the hardscapes to facilitate rainwater management and enable groundwater replenishment. New Home is pollinator-friendly, with a row of elevated planters featuring native host plants lining the edge of the patio. Despite the focus on water use reduction, New Home still allows residents the flexibility of growing fruits and vegetables with a more heavily irrigated orchard and garden area, as one can see on the water zones diagram below. As a result of all of the water reduction strategies mentioned prior, New Home effectively decreased every aspect of its water use relative to LEED, WaterSense, and Energy Star baselines. In total, this meant an annual water reduction of about 141,000 gallons per year, which brings us to a staggering percent reduction of 60.5% and a 60-year water savings of more than $34,000, making New Home's water system environmentally and financially sustainable.
A benchmark home of this size in this climate zone has an EUI of about 39. Making a net zero home is a challenge in this climate zone because there's high heating loads and relatively low insulation. There's a lot of cloudy days. Furthermore, the inclusion of an ADU means that there can be higher energy loads if 2 sets of appliances are being used at the same time. To that end, the mechanical system is designed for maximum efficiency and comfort. An air source heat pump system with indoor mini split units provides maximum efficiency, ease of regulating temperatures in different parts of the home, especially between the ADU and the main home, and top-notch acoustic performance. Ductless energy recovery ventilators are very quiet, provide ample fresh air, and massively reduce ventilation-related energy loads. The fully ductless design saves on construction costs as well. Finally, we have ceiling fans to provide more indoor air circulation. In order to save on heating and cooling, we combine our super insulated airtight envelope with high R values and low infiltration, as well as our highly efficient heat pump system with maximum heating and cooling efficiencies of 290% and 640% respectively, as well as our energy recovery ventilators with a high 91% of sensible heat recovery from the air transported through the envelope. We get further savings from our water system. The water core minimizes piping-related heating losses, the drain water heat recovery recycles heat from drain water, and the heat pump water heater is super efficient with its maximum 375% efficiency, driving down the energy required for water heating. Highly efficient and ADA-compliant appliances from Energy Star's most efficient list, combined with LED lighting and daylighting sensors, which can turn off lights when there's ample natural light available, result in our final savings. In combination, this brings our HER score without PV to 31. With PV, we reach net zero with a HER score of -22. We have an 11.3 kilowatt PV system that makes about 14 megawatt hours of electricity per year. This consists of 36 30-year warranty highly efficient PV panels paired with microinverters, which prevent the shading of one panel from something like snow from degrading the overall system efficiency. For an electric vehicle future, New Home has a level 2 EV charger in the garage. We generate a lot more energy than we consume. We had actually considered 2 systems, an 11.3 kilowatt and an 8.2 kilowatt system. And for the extra $7,000 needed for the larger system, we can get about $4,000 more in electricity generation in the first 10 years. We're also able to be net zero for the whole PV warranty period, since the panels degrade about 1% annually. And we also get protection against further unforeseen circumstances that could compromise the integrity of the envelope. We can offset potential EV charging, and we can reduce the load on the grid, which is why we decided to go with the larger system. So this past year or so, we've seen a lot of grid failures, partial blackouts, rolling blackouts that are due to extreme weather and high energy demands at the same time. So that's why it's important that New Home is able to function off-grid 65% of the time during daytime hours. And furthermore, during peak times, it's able to get 43% of its load met by the on-site PV generation. And overall, we're able to make 37% of our load from on-site generation. In terms of our materials, we've used a lot of reclaimed materials, from our crushed rock structural fill to our cellulose insulation, and we actually are able to store about 34 kilograms of CO2 per square foot in our home of CO2 in our building materials. If we compare that to the embodied carbon of assembling, making, and disposing of the materials in our home of 21 kilograms of CO2 per square foot, we can see that the carbon sequestration within our building is greater than the carbon emissions from making, assembling, and disposing of the materials in our building.
To maximize sustainability and to allow for quicker, more precise construction of the structure, prefabrication of several typical components is planned: trusses, double stud wall section frames, and bay window wall section frames. The superstructure of the home was designed such that it can be broken down into several of these sections, while the sections were designed such that they can fit on a flatbed trailer to allow easy transportation to the job site. Interior modularity and the option for future renovations was considered when designing the home's structure. As such, all loads are bared by the exterior walls of the home only, allowing for changes to be made to the existing interior floor plan without need for structural changes. Without factoring in the price of land so as to focus purely on New Home as an alternative construction, it costs around $60,000 more to build compared to a typical home of the same size in Chicago. Despite the increased costs, when factoring in income unit gains, a significant amount of money can be used to effectively offset the pricing of New Home. On an annual basis, a typical home of this size in Chicago would cost just over $6,000 per year. New Home, on the other hand, because of its energy efficiency and PV capabilities, costs just less than $3,400 per year. Taking this a step farther, we can see that over a longer period of time, in this case 60 years with the ADU being rented for half of that time, the net cost of New Home is nearly $475,000 less than the net cost of a typical Chicago home of the same size, thus making it a very financially feasible alternative to minimally code-compliant construction.
This is how one family may use New Home over time. Ria and Enzo have recently gotten married and moved into New Home to be closer to their places of work in Lakeview, Chicago. They rent out the ADU using the income they receive towards their mortgage. Then, Ria and Enzo have a child named Shreya. To help raise Shreya in her early years, the ADU functions as an in-law suite for Ria's parents. When Shreya gets older, Ria and Enzo rent the ADU out again. As Shreya moves away, Ria and Enzo move into the ADU, allowing them to downsize their living space while staying connected to their community. They rent out the main home, and the lowered annual living expenses with the additional income from the ADU over time allow Ria and Enzo to live sustainably and be part of the Lakeview community for a long time. New Home reimagines modern living in Chicago by providing a healthy and functional home with maximum efficiency in its layout and envelope, decreasing daily impact through water use reduction and net zero energy usage, and using common construction practices with the adaptable ADU to help offset the cost of the home's sustainable features. New Home focuses on marketable sustainability because for something to be sustainable, it must be attainable. We believe the future of new homes is New Home.